Before we start this question, let's talk about the key concept that's going to help us solve the problem. Let's start with an example. So, say I work somewhere and I make $10 an hour. And I work for 2 hours, so I go home with $20. The next day, I start a different job where I make $20 per hour. How long do I need to work if I want to go home with $20 again? Well, I only need to work half as long, so just 1 hour. So notice that when my pay doubled, the amount of time I had to work was cut in half so that I made the same earnings. Let's try another example. Say I work somewhere where I only make $1 an hour. It's a very badly paid job. And I only work for 1 hour and I go home with $1. The next day, I get a raise. The next day, I get $3 an hour. If I'm okay with just earning $1 again that day, how long do I need to work for? Well, I only need to work for a third of the time that I worked yesterday. How else can we express 3 as a fraction? Well, we can give it a denominator of 1. So notice that 3 over 1 and 1 over 3 are just the same fraction, but flipped. And multiplied together, they equal 1. These are called reciprocals, and a reciprocal is just a fraction that is flipped. So let me show you how a fraction multiplied by its reciprocal is always equal to 1. Let's try this with 6 over 7. What is the reciprocal of 6 over 7? We flip it and we get 7 over 6. And what do we get? 6 times 7 on top equals 42. 7 times 6 on the bottom equals 42 once again. The numerator and the denominator are the same, so they will equal 1. So you can pause the video and try a few more examples on your own to see how 2 reciprocals multiplied together will always equal 1. And this is the concept that we're going to explore in order to solve this question. Okay, so let's start with a question. First of all, how do we define the relationship between distance, speed, and time? We say distance is equal to speed times time. So if you need to think about that for a second, just imagine a train or a car is going 50 kilometers per hour and it drives for 4 hours. What distance did it travel? There are 4 hours. Each hour it traveled 50 kilometers, so 4 times 50 is equal to 200 kilometers. Okay, now that that's established, that formula, let's look at our question. Yesterday evening, my journey home from work took 25% longer than usual. So what does usual mean? Usual means 100%. 100% means the amount of time that it takes me to get there didn't change at all, but today it took me an extra 25% longer than usual. So 100% plus 25% is equal to 125%. How do we express that as a fraction? We give it a denominator of 100. 125 over 100. This will simplify to 5 over 4. Let's plug this into our formula. So you traveled a certain distance between home and work. We don't know what that distance is. you traveled at a particular speed and you took 5/4 of the time that it usually takes you. Now, what do we need to multiply the speed by in order to retain the same distance that we usually have? Because the distance hasn't changed. But if we took longer, that probably means that we walked more slowly. And using our knowledge of reciprocals, we know that in order to keep the same distance, we have to multiply by the reciprocal of 5/4, which is 4/5. How do we express 4/5 as a percentage? There's a number of ways we can do it, but we can multiply 4/5 by 100%. These will cancel out. This becomes 20. So in the end, we get 80%. So your speed was 80% of what it is usually, but the question is, by what percentage was my speed reduced? So we'll have to subtract 80% from 100% in order to get 20%. So your speed was reduced by 20%. You were 20% slower than usual. Let's look at the second part of the question. So in this case, we want to increase our speed so that we can decrease the amount of time our journey takes. So this time, specifically, we want to increase our average, we want to reduce by 20% the amount of time that the journey takes. So we can say 100% minus 20% gives us 80%. So we want to take only the 80% of the time that we usually take. And in terms of fractions, 80% can be expressed as 80/100, which can be simplified to 4/5. And we can go ahead and plug it into our formula. Distance is equal to something multiplied by the speed times some fraction of the time. So we have done something to the time. We have reduced our time to 4/5 of what it took originally. And so now our speed is going to have to be the reciprocal of 4/5 of time, which is 5/4. And how do we express 5/4 as a percentage? Common factor between 4 and 100 is 4, so this becomes 1. This one becomes 25. 5 times 25 is 125%. So your speed is 125% of what it used to be. So you increased it by 125% minus the 100% that you usually take, leaves the percentage that you increased your speed by. And that's the answer.